Hi all, welcome to another session of BoilChem Tutor. In this session, I am discussing about the basic properties of amines. In the earlier session, we have discussed amines are classified into three types, that is primary, secondary and tertiary amine, that is 1 degree, 2 degree and 3 degree amines. In primary amine, there are one alkyl group are attached to the nitrogen atom of the amine. But in secondary, there are two alkyl group attached to the nitrogen atom of the amine. But in tertiary, there are three alkyl groups are attached around the nitrogen atom of the amine. So when we are discussing these three amines, that is primary, secondary and tertiary, each nitrogen atom is having a lone pair of electrons. So this lone pair electrons has a capacity to attract or share a proton. So this makes amines basic in nature. So the basic character of amine are further confirmed by adding an acid to primary, secondary or tertiary amine. It results in the formation of a salt. And after the formation of the salt, when we are adding a base also, it can revert back to the primary, secondary or tertiary. So we have discussed that primary, secondary and tertiary amines are basic in nature. Next we have to discuss which is more basic, that is out of this primary, secondary and tertiary, which is more basic in nature. So to compare the basic strength of primary, secondary and tertiary amine, we are reacting the primary and secondary or tertiary amine with water. So each has a capacity to form alkyl ammonium hydroxide. But the formation of alkyl ammonium hydroxide for primary, secondary and tertiary amine will be different. So by considering the formation of alkyl ammonium hydroxide as an equilibrium reaction, and if we are finding the equilibrium constant experimentally, we can find out the basic strength of each amines. And since the amines are basic in nature, so the equilibrium constant, that is K, it is expressed in terms of Kb, that is basicity constant. And this basicity constant is equal to the ratio of the product concentration, that is product formation means it is the alkyl ammonium hydroxide concentration to the reactant concentration, that is whichever amine we are taking its concentration. So when we are taking the ratio, we can find out the Kb value. So if the product concentration, that is if the formation of the alkyl ammonium hydroxide tendency is high, means its Kb value will be high. And similarly, if the product concentration is less, that is if the formation of the positive charge on the nitrogen atom is less, means its Kb value will be less. So larger the Kb value, larger will be the basic character. Similarly, we can express in terms of pKb. pKb is equal to negative logarithm of Kb. So if the Kb, that is if Kb is high, means its basic character is high. Similarly, if pKb is high, means it will be least basic in nature since it is the negative logarithm of Kb. So next we can compare the basic character of ammonia with alkyl amines. Alkyl amines means it has primary, secondary and tertiary amine. So we are comparing the basic character of ammonia and primary, secondary and tertiary amines. So by experimentally, when we find out the pKb value of ammonia, it is found to be 4.77. But when we are finding the pKb value of alkyl amines, it comes to the range of 3.65 to 4.22. So by comparing this, we found that pKb value of alkyl amines are small. That means it will be stronger base when compared to ammonia. So let us discuss why ammonia is having a least basic strength than alkyl amines. When we are looking ammonia, nitrogen atom is surrounded by 3 hydrogen atoms. But in alkyl amine, the nitrogen atom is surrounded by one or more alkyl group. This alkyl group is having a inductive effect, that is it is having a plus I effect, that is it is having an electron releasing capacity. So in alkyl amine, it is having one or more alkyl group, and that means it is having an electron releasing capacity in the alkyl amines. But in ammonia, there is no such electron releasing group because it is surrounded by 3 hydrogen atoms. So when we are taking the alkyl amine also, that is primary, secondary and tertiary amine. In primary there are only one electron releasing group, that is one alkyl group. But in secondary there are two electron releasing group, that is two R group are there. But in tertiary there are three R group, that is three alkyl groups are present. So the increasing the electron releasing group present in the nitrogen, present around the nitrogen atom, which make more availability to share a proton, which make the lone pair electron around the nitrogen atom to attract more easily. So the presence of electron releasing group, that is presence of one or more electron releasing group around the nitrogen atom, increases the availability of the lone pair electron for the protonation. So that is why alkyl amines are more basic when compared to ammonia. Primary, secondary and tertiary amines. In tertiary amines there are three alkyl groups are present, that is there are more electron releasing group. While in secondary there are only two alkyl group. That is, when comparing tertiary and secondary, the presence of electron releasing group is less in secondary. And when we are comparing secondary and primary it is only having one electron releasing group. That means the presence of electron releasing group is less. So in tertiary there will be increasing the availability of lone pair electron for protonation around the nitrogen atom. So tertiary will be more basic when compared to secondary and primary. So out of this ammonia and the alkyl amine, tertiary will be more basic, then comes the secondary and then comes the primary and then only it goes to ammonia. So we found that the main important factor affecting the basicity of amine is the plus I effect or electron releasing group. So when the electron releasing group is increases means it increases the availability of electron for the protonation around the nitrogen atom. But one important point to note is that the order of basicity of amine is different in gas phase as well as the aqueous phase. So in gas phase, when we are discussing the basicity of amines, we are mainly considering the plus I effect. So increasing the plus I effect, increasing the basicity. So in gas phase, tertiary will be more basic, then secondary, then primary, and then comes to the ammonia. So in aqueous phase or in aqueous media, the order of basicity of amine is different. So in aqueous media, we have to consider other factors by comparing the strength of the amines. That is, one important factor is the solvation effect and another important effect is the steric effect. So let us first deal with the solvation effect. In solvation effect, we are adding water to primary, secondary and tertiary amines. So when we are adding water to primary amine, we found that it gets protonated and there are three hydrogen atoms surrounding the nitrogen atom. But in the secondary, when we are adding water, there are two hydrogen atoms surrounding the nitrogen atom. Again, when we are adding water to the tertiary amine, there are only one hydrogen atom is surrounded around the nitrogen. So when we are considering the protonated primary amine, it is found that there are three hydrogen atoms around the nitrogen atom and each hydrogen atom is attracted by other water molecule by hydrogen bonding. That means there is more stabilization by hydrogen bonding. But in secondary amine, there are only two hydrogen atoms and two hydrogen atoms are again stabilized by hydrogen bonding with other water molecule. But in tertiary, there is only one hydrogen atom and so it has least capacity to stabilize by hydrogen bonding. So the order of basicity of amine in aqueous phase by solvation effect is by primary will be having the stronger basic character, then secondary, then goes to the tertiary. So another important factor affecting the basicity of amines in aqueous media is the steric effect. So when we are comparing alkyl amines, that is primary, secondary and tertiary, in tertiary amines there are three alkyl groups. That means overcrowding is high. That is steric hindrance is maximum. So the hydration is least. But in primary amine there is only one alkyl group, that means overcrowding is less and hydration is easy. So according to steric effect also we can find out the basic strength as order as primary greater than secondary greater than tertiary amines. Experimentally, when we are calculating the basicity of amine, we found some exception when the alkyl group is methyl and when the alkyl group is ethyl. So when alkyl group is methyl, we found the order of basicity as, that is, secondary methyl amine will be more basic, then comes the primary, then comes the tertiary methyl amine. Why? Because here inductive effect play an important role than the solvation effect. And moreover, here methyl group is very small in size, so inductive effect is maximum. So secondary will be more basic, and then primary, and out of primary and tertiary, primary will be more basic, that is primary methylamine will be more basic than the tertiary methylamine, because in primary there is more inductive effect and there is more availability of lone pair electron for the protonation than the tertiary amines. But if the alkyl group is ethyl group, then the order of basicity again differ. That is, it is found experimentally that secondary is more basic, secondary ethylamine is more basic, then comes the tertiary ethylamine, and then it comes the primary ethylamine. Why? Because here the solvation effect play an important role than the inductive effect. Because when we are considering the inductive effect, ethyl group is having the bigger size, therefore inductive effect is less. But the hydration power, that is solvating power, is high. That is why secondary ethylamine is having higher basicity, and then comes the tertiary ethylamine, and then comes the primary ethylamine. Comparing the aromatic amine, that is aniline, and the ammonia, we found that aromatic amine are less basic than the ammonia. Why? Because aromatic amine, that is aniline, is having a lone pair electron on the nitrogen atom and it is having a high resonating effect. That means amine is having an electron releasing capacity, that is this lone pair electron start donating to the benzene ring. So the availability of the lone pair electron on the nitrogen atom become less. That is why aromatic amine that will be less basic than the ammonia. So it will be less available for the protonation. The presence of different group on the aromatic aniline increases or decreases the basicity of amines. That means if an electron releasing group are present on the aromatic amine, that is aniline, it will increases the basicity of amine. That means if one more amino group or one more ether group or one more alkyl group are present on an aromatic amine, it will definitely increases the basicity of amine. But if an electron withdrawing group like aldehyde or acid or nitro group are present on an aromatic amine, it will decreases the basicity of amine. That means it will not available for the protonation, that is nitrogen won't make the availability for the protonation. So that is all in this session. Hope you like this session. Stay tuned for the next session. Till then, bye.